just for the audience, just so that they kind of understand in some ways, like how does this tangibly, practically even happen? That like, oh, you did something, and then it doesn't, you can't replicate it. Like, what do you mean, Tim? So at least in my experience, I'll give you my example, and then you can. I'm sure you have other examples that you can give as well that would be helpful for people. But for instance, for myself, when I used to be a many years ago a pseudo chemist, I would we had to put these DNA molecules on these, functionalize them on these nanorods, right? These really really tiny structures that were made out of gold, and we followed the publication. And just for the life of me, I couldn't get it to work. I just couldn't get it to work, right? I'm like, I tried like maybe slowing things down, changing these parameters, changing those parameters. And what ended up happening was my colleague had a chat with the postdoc or the PhD student at that time at a conference and said, "Hey, my buddy's been trying to replicate this. Like, why? Like, can you give him some tips? Why isn't it working?" And then the person said, "It works like 1 out of 10 times. Like this method." I was like, "Oh my goodness, that's exactly how often it works for me as well." So just it's these nuances. So it's not that they fake the data; it's just that it's incredibly hard. They don't like tell you that extra little bit. Oh, it only works 1 out of 10 times.
Yeah, that's a good example too, by the way, because like to me, that's really important to know. Not just because, oh, right, I can calibrate my expectations. It's also like, what do I do with this? Because it's only working 1 out of 10 times. Like I can't. It's not something that I can itself repeat constantly. So I think, yeah, that's definitely a big piece of it, which is, and there's a term that we use in this, the field uses, right, which is selective reporting, right? So in that case, somebody selectively reported the 1 time out of 10 that it worked. That's really not desirable. It doesn't mean, again, that you can't repeat it. Clearly you did. It's just that crucial information, that really, really important nugget was gone. The other thing that we see that's really common is, and we can use, your example again, which is a lot of the time when you look at the published paper, does not have the detail that you need it to have. And I think that's like and again, there's no intention here, or at least I'm not going to infer any intention. It's just kind of like the state of affairs, which is it's really weak on details. And a lot of times it'll say standard procedure or as done previously. And you go to this reference and I've done this. You go down this train, you could be like 20 years in the past and you're like, is that really what you did? The same thing from 20 years ago? I don't think so. The reason I think we lose this is, one, we're super focused on the method and on the results and not the methods, even though the methods are crucial to the results. So that means that like the detail, that hidden, that, the devil's in the detail, that the detail is there, but it never popped out. And if you don't share it, no one knows. But the reason you don't share it too is you might not know it matters. So when we do these experiments, right, they're incredibly complex, especially when you do an animal study. So many factors at play, and so many that you do not want to have as an impact. So, right, does the time of day when I do the experiment, does it matter? I hope not. I'm doing a biochemical experiment. Time of day should have no matter, right? Does the humidity in the room matter? No, it should not matter, right? But there are these natural fluctuations we don't measure. And so we don't capture these details because we don't think that they matter. Or I say, oh, just spin the tube. But really what you did is you flicked the tube. And you're like, I don't think, it doesn't matter. Who cares? But a replication confronts that instantly, right? Because it's saying, okay, well, you told me it doesn't matter, so I'll do what I want to do, right? I'll super spin the tube because you told me it doesn't matter. And then you get a completely different result. And again, I think this is why it's so hard, is because we don't want these details to matter. But when they do, then we have a problem, because now we're going to have to confront ourselves. The part that I find more interesting, right, is like you get this all the time, especially in biochemical experiments and almost anything, chemistry experiments, where there's tons and tons of moving parts. And you're like, okay, well, should I do it all exactly the same every single time? And I'd say, well, yes and no, right? Like, does it matter from a biological standpoint is the question I have in these cases that we were doing, right? Which is, if it doesn't matter, if flicking, spinning, if I can't have a biological reason for it, in theory, yeah, a replication, somebody doing it independently, like yourself, like that's actually very helpful. It confronts that. There's no reason this should matter, so why does it matter? Which means when you replicate the result, that means there's tons of variation, and that gives us more confidence in the finding. Cool. I specified the details I thought were necessary. Looks like I got it right. We can keep moving up that translational pipeline. If you don't specify all these details and somebody says, I can't get the same result, and you're like, oh, you know what? It turns out it was because you have to flick it 2 times, right? Then you might say, oh, cool, I got the same result. But then you have to ask yourself, why does flicking 2 times matter? Because if I don't have a good reason for it, like what's going on, right? What am I creating here? Because you can get these artifacts, and we're terrified of that, right? Nobody in science wants to have their result due to a lot number, a specific, formulation. It's like, oh, only that one supplier is the only way I get the result. Like, you don't want that, but sometimes that happens. And so we need to kind of confront ourselves constantly. And I think it's just, unfortunately, like, that's kind of the state of affairs we're in right now, which is the methods are so short that we're missing so many details that, whether it's, flicking the tube, or whether it's just saying use standard procedure, and you're like, there's 20 different standard procedures. Which one should I use? I think that's to me like the low hanging fruit, which is, let's do a little more specification of what did you actually do, and just share with me what you actually did.